Hi everyone, welcome back to Abra Knowledge channel. Today we are going to discuss hypothesis using mind map, and this is the typical mind map one, and we are going to discuss more from the statistic point of view. Just see that what is statistic. Statistic is a testing begins with a theory or begins with a claim or begins with an assertion that about a particular parameter of a population, right? In order to test the population, we just do that testing in order to arrive to a conclusion. There are two type of one when you do a hypothesis. One is null hypothesis, one is an alternate hypothesis. Null hypothesis is the current belief in a system or the current cycle time, current data, current belief, right? And the alternate hypothesis is an opposite to null hypothesis, a specific inferences you would like to prove. For example, like say cycle time has improved, right? And you wanted to really prove that whether the cycle time has been reduced significantly or not, right? Whether the accuracy has been improved, whether the on-time delivery has been improved, whether the first pass yield has been improved. All of that you can test it, right? And the alternate hypothesis is nothing but an opposite to null hypothesis. And we're talking about null hypothesis again, state of no change or equal. And the generally the null hypothesis carry a signal of sign of equal to, always about population, always about mu, right? Not about the process mean, right? We are talking about the population, parameter of a population, right? And the alternate hypothesis is where a not equal to symbol is being expressed, and always about population and not about the process mean. And this is very interesting. Predominantly we know these two, right? One is zero point 0, 0.05, that is 5%. We are going to reject the null hypothesis, meaning statistic proof that alternate hypothesis is correct, right? Or in other words, statistically significant. And if it is greater than 5%, we are going to accept the null hypothesis, meaning there will not be any change, there is no change, or do not reject null hypothesis. And statistic prove that H naught is may be accurate or may be correct, right? So that's what it believes. So further granularity I would like to provide on this topic. So just 5%, and depending upon the situation, you can also alter your alpha value, or meaning like confidence interval value. For example, 0.05, sometime you can give 0.01, 1%, sometime you can give 0.05, sometime this is not a, really important one, you can give up to point no, 1 also as well, right? That means 10%, right? So let's talk about that granularity furthermore. 0 to 0.01, that is 1%, that means highly significant. In other words, that overwhelming evidence that H1 is true, right? Between zero point 0.1 to 0.05, right? Zero point 0.01 to 0.05, that is deemed to be significant, meaning strong evidence that there is H1 is true. And there anything greater than 5 that comes into the canopy of H, accept the null hypothesis or do not reject the null hypothesis, right? So now what we can say, 0.05, that is 5%, or and up to 10%, not statistically significant, or we can say weak evidence that H1 is true, right? And greater than 10%, that is 0.01, and not statistically significant, little to no evidence, or little evidence or no evidence, right? H1 is true. And there are two type. This is the granularity. Let's talk about the decision making. So while taking the decision, there could be two error is possible, right? These two error, type 1, type 2, or alpha or beta error, it's been expressed in various way or various examples and all that. Let's talk about that type 1 error. For example, this is the statistical decision that reject the null hypothesis, but actually we are accepting the null hypothesis. That's called type 1 error. And type 2 error is actually statistically we need to accept the null hypothesis, For example, let's say that the value is greater than 5%, but we are rejecting the null hypothesis, that is type 2. In other words, type 1 is also called alpha risk, that means rejecting the good one. And type 2 is beta risk, accepting the bad one, right? So this is the one, reject the null hypothesis, that means reject, that is correct decision, and you're doing it opposite, that is type 1 error. And do not reject the null hypothesis, the correct one is to have that accept the null hypothesis, that's the correct decision. And you're doing it vice versa, that is type 2 error as such. Let's talk about a little bit more detail and on the tool set. This is very interesting part, right? Depend upon the entire statistic, whether it's a control chart, whether it's a process capability, whether it's MSA, whether anything and everything, the changes depend upon the data, and specifically depend upon the data type, whether the data is continuous data, variable data. Exactly in the same thing, hypothesis also carry no difference. And hypothesis also does carry the same differences depending upon the tool. For example, let's say you wanted to focus on mean, and single sample, two sample, or multi-sample. So if it's single sample, you can take one sample t test, t for tail, one sample tail test or t test. A two sample, you're gonna test it like two sample. In two sample, I wanted to talk about one point, that when you're doing it, for example, in a past video, I compared Sachin performance with versus Virat Kohli performance, right? When you're talking about two tails, right? So it is also, we are also talking about two histograms, right? Two sample meaning like hypothetically accepting or rejecting it. That means two of the curve, two of the histogram we are accepting or rejecting it, right? So multi one, the ANOVA is the best method, analyze of variances, where you can analyze of variances ANOVA. You can easily compare the mean with an interaction. That is what ANOVA is all about. Variance, let's talk about the variance. You wanted to talk about the variance alone. You wanted to compare the variance. If it is only single sample is there, then single variance is acceptable. Two, and you can do a two variable or F test if it is for normal data, and Levin test is being carried out for non-normal data. And how to know that normal data and non-normal data, I have already covered in my past video. And if the p-value is less than 0.05, the data is not normal. If the p-value is greater than 5%, the data is normal when you do a normality test, right? So when you say multi-sample test, that means you can do a test for equal variances, or Bartlett test we can do it. And or if it is non-normal data, if the data is like is have less than 5%, then you can also do Levin test also as well. So one of the tests will depend upon the data, the whatever the value you got it in the normality test, you can carry out. Similarly, variances, and again, if it is single sample, you can do one proportionate data proportionate, and if it is two proportionate, if it is multi, you can do chi-square test, you can do it, right? So this depend upon the data you can. I would like to give one example to illustrate the right side, the type 1 error and type 2 error. Let's talk about this one. And example number one. There are two examples being quoted. Let's talk about example number one. Example number one, H1, H0, that is null hypothesis. A person is free of a particular disease, right? And the medical report shows that the person is free of disease, right? That's is a perfect one, right? Do not reject the null hypothesis, right? But in reality, the person actually has the disease. That is called false negative, and also called type 2 error. Let's talk about an alternate one. Again, a particular like the alternate, this is actually, you can see that null hypothesis always is a state of innocence, right? A person is free of particular disease. Now we are starting with the belief that a person has a particular disease, and medical report shows that the person has a disease. That means we're going to reject the null hypothesis, because it's alternate, right? We're going to reject the null hypothesis, but in reality, the person is free of the disease, right? That is called, refer as a false positive, and that is also called, because it is free of it, that's why it is called positive, false positive. That is called type 1 error. So you can see that type 1 error has a different name, right? One is called alpha risk, one is called false positive, type 2 is actually beta risk. It also got a name of false negative. It also got a name of so when you do that, accepting the bat, that means that is type 2 error as such. Let's talk about example number two. In example number two, it's a judgment one. So it's a very interesting one. An accused person is innocent, right? That is the null hypothesis. An alternate is accused person is guilty, right? Let's talk about that from the null hypothesis standpoint. A accused person is innocent. Verdict that finds that the accused is innocent do not reject the null hypothesis, but in reality, she is actually guilty, right? The person is guilty. That false negative, that is called type 2 error. And the verdict, and this is another one. The verdict, again, we're talking about alternate one, and then accused is person is guilty. Verdict that find that accused is guilty, reject the null hypothesis. But in reality, accused is actually an innocent, right? So that means it is a false positive, type 1 error also we can call it. So I hope you find this very useful. I collected this particular note from the various book. One is business statistic, and you also have Sanjeev Jaggi, who was the author. And another one is statistic for manager using the Microsoft Excel. 8th edition and 10th edition I have used Pearson version asset. I hope you enjoyed this video. Please do like, share, subscribe my channel. You have wonderful day ahead.